Welcome you guys, welcome you all, welcome to Unacademy. A great news to all of you. So you can have a look at now we are in GATE 2024. So Unacademy students have performed very greatly, and so you can see now here 7 AIR 1 ranks from Unacademy students only. You can have a look at now electrical, CSIT, ECE, CH, IN, PI, NM. All these 7 branches Unacademy students have performed extraordinarily. Now it's time for you can start your serious preparation with Unacademy. So to avail the great opportunities. इसीलिए हमने आपके लिए फ्लैट 50% डिस्काउंट आपके लिए लेकर आया. And because of this demand of the students, we have extend this offer up to the 28th of August. According to the demand of the students, this offer we have extended to up to 28th August. You can have a look at now the top educators team is in one frame में आपको available है. You can learn from the top educators. And to avail these opportunities, you can use a code of B V Reddy and you will have a great learning experience from the top educators. Right. And these are the new batches we are starting. You can have a look at now here. And I'm going to start the EMFT subject for ECE students from 31st August onwards. You can enroll for this course to have a great learning experience from the top educators. To join these courses, you can use a code of B V Reddy to avail the great learning experience. And these are the list of books the electrical fellows can able to get. Have a look at now here. Of course, these books are only for iconic subscriptions only. And these are the ECE books. चलो आज का सेशन हम शुरू करेगा. So take this thing here. Today's class we are discussing the AC circuits problems. See this thing here. A 120 volts 50 Hz AC source is switched on. The voltage just after 1/720 seconds is. And we are going to discuss each and every problem of AC from very low level, basic level to high level. So let's have a discussion now. They given 120 volts and 60 Hz frequency they given. So what is this value? Tell me now here. RMS value. So this is given as what? Tell me RMS value. So from this we can get the peak value. So that is V naught is a peak value which is equal to √2 into V RMS. So how much is V naught value? Tell me. 120 √2. And frequency given as 60. So from this omega value, how much we can say? Tell me. Omega equal to 2 pi f. That is omega equal to 120 pi radians per second. Now you can tell me now here expression, the voltage expression V of t, which we can say this as what? V naught into sine omega t. So that is V of t. V naught is how much? You tell me. 120 √2 into sine of omega value 120 pi t. They given a t is equal to how much? 1/720 seconds they are asking. So then V of t, which is given as 120 √2 into sine of 120 pi into 1/720. So yeah, simplify this thing here. 0 cancels, 12 6 now here. So V of t will come it as what? 120 √2 into sine of pi by 6. Sine pi by 6, that is sine. So here what we'll get now here? Sine pi by 6 is a, which is equal to 1/2. Sine 30 value how much? 1/2. So from this we can get V of t as what? 120 √2 into sine 30 is 1/2. So we'll come it as what element of 60 √2. So option C. An ammeter in AC circuit reads 4 amperes. The maximum instantaneous amplitude is. So they are given the ammeter. Ammeter will measure what currents are RMS currents. That means they given the RMS value given as what? 4 amperes. From this, can you tell me the peak value? That is 4 into root 2. So that means I of t expression, what I can say, tell me now here, I naught into sine of omega t. So this is I of t, which is equal to 4 root 2 into sine omega t. Now what is the maximum value of this current can be now here? This can be maximum when sine omega t is 1. So this is what I can say now here. The maximum instantaneous current, that is nothing but I naught, which is equal to 4 root 2. Next, an AC having a peak value of 1.414 is used to heat a wire. A DC producing the same heating will be okay. That means indirectly they are asking to find the RMS value, isn't it? Now they given the peak value of AC, which is given as 1.414 amperes. And what is the RMS value? Tell me. That is I naught by root 2. So how much is value? Tell me. 1.414 na by what we can say now, root 2. So which is equal to how much? So which will come it as what you tell me now here? Simplify 1. This is also root 2 only na. So option D. Next, an AC circuit is given as like this. They ask him to find the RMS values. So right, tell me now I is equal to I1 into cos omega t plus what? I2 into sin omega t. So for this cases, what is the RMS value? We have given standard formula for this thing. That is I1 squared by 2 plus I2 squared by 2. Since sine and cos are orthogonal, directly we can apply the formula. Next, a hot wire ammeter. Hot wire ammeter can able to measure both AC as well as a DC. Next, the RMS value of an alternating current of 50 Hz frequency stands. That means RMS value given. So IRMS. RMS value given as a 10. So from this, can you tell me the peak value? That is 10 root 2. Peak value is how much? 10 root 2. Okay, next, what are they given now here? Frequency given as how much? 50 Hz. From this, we can get the time period is what, tell me now here? 1 by frequency. That is what, tell me now? 1 by 50 seconds. Now what they are asking here, the time taken by the alternating current in reaching from 0 to maximum value. Means what they are saying here, 0 to maximum value. So this is how this AC signal now, tell me, sine wave now like this sinusoidal form. We need what, tell me now, 0 to maximum value. Here this current is 0. Here this current value 0, and here this current is what we can say here maximum value. This is I max. Right. So you can tell me now here. So at this location कितना टाइम लगेगा इधर यहाँ से यहाँ तक आने के लिए? So ये this is कितना टाइम लगेगा? So this is t by 4. So कितना टाइम होगा? Tell me now. T is equal to what? T by 4, which is equal to what? Tell me now. Capital T is 1 by 50, so it is 1 by 200. 1 by 200 seconds. So कौन सा option? Tell me. Yes, so option D. Peak value is 10 root 2. So that means what tell me? 14.14. And this t value, how much will come here? 5 into 10 power minus 3 seconds. Next one. The potential difference across a circuit element in steady state is higher than the EMF of the current source. Okay. The potential difference is higher than the EMF of a current source. In case of DC, the maximum potential is only the supply only. If it is more than the supply voltage means it must be a AC circuit only. AC circuit voltage across inductor and capacitor is more than the supply voltage. More than the supply voltage, and a resonance will happen voltage across inductor, which will be given as what element of JQ into this is the VM, where VM is the supply voltage. VM is a supply voltage and Q is a quality factor. Q is a quality factor. So from this you can see now here voltage across inductor, which is what tell me now is amplified by quality factor. Next VC, which is equal to minus J into Q into VM. So this is voltage across capacitor is amplified by quality factor. This can be happens only in case of a AC circuit under resonance conditions, and but DC it is not possible. In an AC source is rated as 220 volts 50 Hz. The average voltage calculated in a time interval of 0.01 seconds is. First of all, frequency given as how much you tell me? 50. So can you tell me the time period now here? 1 by frequency, this is 1 by 50. So this value which will come it as what tell me now here? And 0.02 seconds. 0.02 seconds. Now they given the time interval duration, that is delta t, which is given as what I mean of 0.01 seconds. In this interval they are asking, right? Now if we see this voltage expression V of t, from wave to wave, now here this is, if I call this is the sine wave, now I can say this is 0 and this is 0.01 and this is 0.02 seconds. Now they're asking the duration is what tell me now here? 0.01. That means that is not a t by 2 duration. T by 2 duration. Agar if you have calculated this average value, so that is from here to here. That is, this is how much duration of t by 2. T by 2 is what tell me 0.01 seconds. This value non-zero. So why? Because we have only the positive part is present, right? We have only this positive part is there, positive part area. But लेकिन so here अगर मैंने calculated, if I have calculated my average value, so only the duration is t by 2. Now if I did like this, and from way to way to tell me now here, this is, here this is 0, this is t by 4 and this is t by 2, this is 3t by 4 and this is t. If I have calculated this is in this interval from, let us consider, and how much this duration tell me, this is also t by 2 only, na? Now you can see this thing here. In this duration, here we have a positive part area as well as this negative part area is there. So in this case, the average value 0. In this case, average value, how much? 0. In this case, average value is what? Non-zero. They has mentioned a duration of 0.01 seconds, but they didn't mention whether 0 to 0.01 duration they mentioned. Try to understand. So this means this can be what I can say now here. It may be 0, may not be 0. So that's the reason we cannot conclude this is absolutely 0. May be 0, must be 0 is not correct. Non-zero also possible now. Is never be 0. This is also not correct. And this may be 0. Next. Effective value. Effective value means what? Tell me RMS value. They given this current, which is what? Tell me now here, 2 plus 4 into cos of 100 pi t. Now tell me now what is the RMS value? Tell me, which is equal to square root of what? Tell me now, 2 square plus 4 square by 2. So how much is value? Tell me now here. 4 plus 16 by 2. This is 8 now. So this means what we'll get now here? Root 12. That is 2 root 3. Next. If alternating current in a circuit is given by, then the time taken by the current to change from RMS value to 0. RMS value is how much, you tell me? RMS value is I naught by root 2. RMS value to 0. 0 to RMS value both are same. So that means what we can say? I of t, which is given as I naught into sine of 2 pi nt. So this is value changing from where to where? RMS value. 0 to RMS value we are calculating. So that is I naught by root 2, which is equal to I naught into what I can say? Sine of 2 pi nt. So this I naught will get cancelled. That is 1 by root 2 into what? Tell me? Equal to sine of 2 pi nt. So from this what I can say? 2 pi nt, which is equal to pi by 4. Now this pi cancels. So we need to get what element of t now? T is equal to what now here? 1 by 8n. Right. Chalo, next problems. An alternating EMF of E is equal to 200 root 2 sine 10 pi t is applied to a 10 microfarad capacitor through AC ammeter. The ammeter reading is, they connect apply to what? Tell me now here, capacitance C value given 10 microfarads and supply. So this is voltage which is given as 200 root 2 into what? Tell me now, sine of 10t is applied to a this much ammeter. AC ammeter will measure the RMS value. So this means from this we can get the XC. XC is equal to 1 by omega C. How much is value? 1 by omega value 10 and C value. So 10 into 10 power minus 6. 1 by omega C. So which will come it as XC value how much? 10 power 4. XC value we got 10 power 4. Now I need what? Tell me now here? Current. So we'll find the peak value first. I naught is what? Tell me now here? 200 root 2 by what? Tell me now? 10 power 4. So how much will come here? So this is 2 root 2 into 10 power minus 2. That is I naught value, what I can say now, 20 root 2 into 10 power minus 3 is milliampere. So now what is the RMS value? Which is equal to I naught by root 2. Which is equal to what, tell me now, 20 milliamps. Next, in a circuit, capacitor blocks a DC and but can allows the DC. Capacitor allows AC but blocks DC. The reactance of a capacitor for DC is how much? For DC, omega value how much? Omega value 0. That means Xc is equal to 1 by omega C. So which is, it will behave like what, tell me now? Open circuit. It behave like a open circuit. If it is behave like open circuit, then it does not allows. So that's why capacitor blocks DC. Capacitor blocks DC. The angular frequency of AC circuit at which 1 mH inductor has a reactance of 1 ohm. What is a reactance of an inductor? Which is given as omega L. They are saying the reactance is 1, omega is equal to, we need to calculate now, and L value 1 into 10 power minus 3. So omega is equal to how much? 10Q. So this is radians per second. Next one. Reactance of a 1 by pi capacitor in 50 Hz AC is, reactance of a capacitor Xc given as what? 1 by omega C, which is equal to omega equal to 2 pi f. F is given 50 and C value 1 by pi. So that's why Xc will becomes what, tell me now? 1 by 100. So that is 10 power minus 2 ohms. Next, a resistance of 10 ohms and inductance of 100 milli are connected in series. Okay. The phase difference between the current and the applied EMF is phase difference between voltage and current. Phase difference between voltage and current. Voltage and current, that is phi is equal to tan inverse of what we can say now, XL, inductor na, XL by R. So that is how much will come? Tan inverse of XL is equal to omega L by R. That is phi is equal to tan inverse of what, tell me? Omega is 100. L is what, tell me? This is 100 into 10 power minus 3 by R is equal to 10. So you can see now the zeros will get cancelled. So you can see now phi is equal to what? Tan inverse of 1. So that is phi is equal to, this is pi by 4. Next, a DC is sent into a circuit having 10 ohm resistor and a pure inductor. Okay, the impedance is given as, okay, DC. For DC, what is the reactance now? XL is equal to omega L, omega equal to 0 now, that's why 0. So the impedance, which is nothing but what, tell me, square root of R square plus XL square now. So this is nothing but simply R only. That is the impedance of the circuit is what, you tell me now, 10 ohms. when 100 volts DC flows in a solenoid is like an inductor. The steady state current is a 10 amperes. Okay, so they are saying this as a case 1. Case 1 is a DC, 100 volts DC they apply. 100 volts DC they apply. Now you tell me now how it is for inductor. So for DC, inductor behaves as what? Tell me, short circuit. Inductor offers the XL value how much? 0. And this DC voltage is 100 volts and there is a flow of current I which is how much? 10 amperes. From this, so here we can say the impedance is given as what? Tell me now, voltage by current. So how much this value? Tell me now here, 10. And that should be equal to R, I can say. In the circuit now here, reactance of inductor 0. So that's why R is equal to how much? 10 ohms. Next. Next. Next they asking here. Now say case 2, they taken as what? Tell me now, AC. Supply is 100 volts and 50 hertz frequency. Now they given this is AC now here. For AC case, now you can tell me resistor, inductor. Now the supply is a AC supply. So this is R. R we have calculated this value. So 10. And this XL value we don't know. And this is the current value given us. How much now? This current is a 0.5 amps. And supply is a 100 volts. Now you can tell me now here Z is equal to what we can say. This is 100 by 0.5. And this is equal to what? Tell me now, 200 ohms. What is Z from the circuit? You tell me now here. Z is equal to from the circuit square root of R square plus XL square now. Z value is a 200. So we can say 200 square, squaring on both sides. R value how much? 100. 100 square plus XL square. So R is 10 only now, sorry. R is resistance is 10 only, so 10 square. Yeah, simplify this thing, we can come this XL value. Yes, simplify this can be, I think so, compared to 200 square, 10 square will be almost neglected. Negligible is still very small value. So XL value, which will come nearly as what element of here. So this is nearly, I can say this is 200 only now. XL is equal to omega L, which is equal to 200. So from this L is equal to, that is 200 by omega. Omega is equal to pi f. That is what we can say now, 100 pi. So how much this value? Tell me. And inductance value 0.64. So option is A. In a AC circuit containing an inductance and a capacitance in series, the current is maximum when the inductance is 0.5 and the capacitance is 8 microfarad. The angular frequency is, they are saying it as what? Tell me now, current is maximum. Maximum current is possible only under resonance only. Maximum current at resonance maximum current will flows. Okay. Now, so that means Angular frequency, this is omega naught, which is equal to 1 by square root of LC na resonant frequency. So that is 1 by square root of L value, how much here? 0.5 means 1 by 2. And this 8 into 10 power minus 6. So this omega naught will come to, this is 1 by 2. Yes, into what element of 10 cube. So this is equal to what element of 500. Sorry, 500 radians. No? Yes. Angular frequency. Yes. In a LR circuit, the AC source voltage is 220. The potential difference across the inductor is. Now, so the circuit is given as RL circuit. For this RL circuit, the voltage V, which is given as square root of what element of VR square plus VL square. They ask him to find the potential difference across resistors. So that is V square minus VL square under root, which is equal to VR now. So that is VR is given as what, tell me? AC source voltage given as 220 volts minus inductor voltage 176 square. So option D. Next. A coil of resistance 2000 ohms and self-inductance given 1 has been connected to an AC source of frequency. The phase difference between voltage and current is phase difference between voltage and current, that is nothing but what, tell me now here, phase angle of impedance, that is given as what, tell me, XL by R. RL circuit now, XL by R. So that is phi value, which will come it as tan inverse of XL is equal to omega L. Omega value how much? So frequency given omega L by R. So this is phi is equal to tan inverse of omega equal to 2 pi f, that is 2 pi into what we can say now 2000 by 2 pi L. L is given as 1 by R is 2000. So this value 5 will come it as what, tell me now? Tan inverse of 1, that means which is equal to 45 degrees. Right. Next one. In a AC circuit, the voltage across L, C, R in series given 60, 20, 30. The applied EMF is the applied voltage, means source voltage, which is given as the relations we know now, that is V squared, VR squared plus VL minus VC whole square. So V is equal to square root of VR square means 60 square plus, okay, sorry, resistor is how much? 30. 30 square. Inductor is what, element of 60 minus capacitor is 20. So from this what I can say now here, square root of 3 square plus 40 square. And this is nothing but 15. This is a standard right angle triangle, you might be remembered. 50. Check karo. Next. An alternating EMF of 100 volts is applied to a series RLC circuit at a resonance. Potential difference across inductor and across capacitor given as 400. The potential difference across resistor is, they given that VL equal to VC equal to how much? 400. Right, so that is V is equal to what we can say, square root of VR square plus VL minus VC whole square. So EMF is given as 100, squaring on both sides, 100 square equal to VR square plus VL minus VC, 400 minus 400 whole square. That means VR value how much here? 100. Yes. Next one. In the given figure, which voltmeter will read 0 voltage at a resonance? And where V1 is what, tell me now, they given this is the voltage across resistor. And this is V2 given as voltage across inductor. V3 is the voltage across capacitor. Now they are asking at a resonance. At a resonance, this sum of inductor voltage, and capacitor voltage. And capacitor voltages is 0. The sum of inductor voltage plus capacitor voltage 0 under resonance condition. That means what we can say now, VL plus VC, which is equal to 0. Now this V4 is given as what, tell me? V4, which is given as VL plus VC. Yes, so here what I can say now, V4 is the sum of the inductor plus capacitor voltage 0. So from this what we can say now, V4 is 0. Next one. In a RLC circuit, 3 elements connected in series by an AC source. If frequency is less than the resonant frequency, yes, means for a frequency less than the resonant frequency, whose effect is more? Inductance effect or capacitance effect? Capacitance effect is more. So this is omega 1, omega naught, omega 2. And this is a resonant frequency. At the resonant frequency, the nature is what, tell me? Inductive and capacitance are nullified. The nature is a resistive purely. At omega equal to omega 1, the nature is what we can say? It is purely capacitive in nature. Here omega 2, this is inductance effect is more. So for a frequency less than the resonant frequency, means at omega equal to omega 1. So the impedance, the nature of the impedance is what I can say? Capacitive. In the series LCR circuit, the voltmeter and ammeter readings are given. Okay. Now they ask him to find what, tell me? V and I ammeter reading and voltmeter readings we need to get. So you can see now here, inductor voltage 400, capacitor voltage also 400. That means voltage across inductor, voltage across capacitor, both are same. So this is called as a resonance now. This is at the resonance. Under resonance condition. So this is V supply voltage. Yes, VR is equal to V only now. So that's why VR is how much? Supply voltage 100 volts. So this current is what we can say, tell me? V by R, that is 50. So we'll come it as 2 amps. Option A. La, 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 la. Next one. In a series LCR circuit, resistance is given 10 and the impedance is 10. The phase difference between the current and voltage. Okay, so you can see now here Z is equal to basically which is given as square root of R square plus XL minus XC whole square. So the Z which is given as 10, so 10 square plus what I can say now XL minus XC. So XL minus XC which is equal to 0, that means XL is equal to XC. So this means both are equal. So means what we can say now here, inductive reactance, capacitive reactance both are equal. And what is a phase difference, you tell me? What is a phase difference between voltage and current, that is given as tan inverse of what? XL minus XC by R, both are equal, so phi value will become 0. They ask you phase difference only now, so 0. A oscillator circuit consists of an inductor and a capacitor. They ask you to find a resonant frequency. The resonant frequency F0 is given as 1 by 2 pi into square root of LC. F0 is given as 1 by 2 pi into square root of LC. L value how much? So which is given as 0.5 into 10 power minus 3. And C value how much? So this is 20 into 10 power minus 6. So you can simplify this thing. What will come here? 2 pi into square root of, yes, how much this value? So this is, if we multiply this thing 0.5 with this thing, will come it as a 10, and this 10 means I can remove 1 0 here, so minus 2 here. So this means 10 power minus 8. So we'll go to numerator. Finally, F0 will come it as what? Tell me, 10 power 4 by 2 pi. Okay. So how much will come this value? 10 power 4 by 2 pi. One five. So this value 1591.5. So check the option. Nearly C option. Next one. In the figure, which of the phasor diagram represent RLC circuit driven at resonance? At resonance, the voltage across the resistor, which is given as I into R, inductor, so this is what we can say, minus j omega L, so plus j omega L into I, capacitor, that is minus j omega minus j by omega C into I. So means inductor, so this is current I. This is I, and VR and I are in phase. So here VL is leading. So this is 90 degrees. VC is lagging. So option C is satisfied. Angle between them is 90 degrees. Next one. In the figure shown, the reading of voltmeters V1 is 40, V2 40, V3 10. The peak value of current is. So V1 means what element of VR, which is 40, and V2 means VL, that is also 40 only, and VC is what element of 10. So here VL and VCs are not equal, so this is not a resonance. And we need, so that this voltage which we got, this as 40 volts, means we can find this current now. I is equal to what we can say, VR by 4, that is what, 40 by 4, which is equal to 10 amperes. The peak value of current, so we got this value, this current is what, tell me, RMS value. So peak value means what we can say now here. So IRMS into root 2. So this is I naught is what, tell me now here, 10 root 2. Option A. Next one. The value of LCR given as like this. They given this as a resistance value 100 and inductance value given as what, tell me now here, 4 milli, 4 into 10 power minus 3. Capacitance value 40 picofarad, 40 into 10 power minus 12. Now they are asking to find what has been a quality factor. Quality factor. The Q factor, which is given as 1 by R into square root of L by C. 1 by R into square root of L by C. So simplify this thing. R value 1 by 100 and inductance is what I mean of 4 into 10 power minus 3 by capacitance is 40 into 10 power minus 12. Simplify, get this value. So this is 1 by 100 and this is what tell me now here, 10 power minus 4, 10 power plus 8. So will come 10 power 4 will come now, check karo. So 100, isn't it? So by doing this thing will come this 100. Check this thing. Next one. The EMF and the current of an AC circuit are given like this. The power dissipated in the circuit is the power dissipated. So now you can see now power dissipated power means average power. Only the resistor will dissipate the power, which is given as what, tell me now, VRMS IRMS into cos phi. So from this we have modified this formula 1 by 2 into V naught I naught into cos phi. So the P is what, tell me now, 1 by 2, V naught is 100, I naught is 100. So cos phi, how much the phase angle is a? Phase difference between voltage and current is pi by 3. So this value 1 by 2 into 100 into 100 into 1 by 2. So this is a 50 into, okay, current given milli now. So this value into 10 power minus 3, 50 into 10 power minus 3. So simplify, power will come it as what? 2.5 watts. The EMF and the current of an AC circuit given like this. The power consumed in the circuit is, now you tell me now, first of all, the power consumed means average power, which is we have seen 1 by 2 V naught I naught into what? Cos phi, where phi is a phase difference. Now you can see phase difference between voltage and current. The given voltage value given as what, tell me now here, 5 into cos omega t. I is equal to what, I mean 2 into sin omega t. Phase difference is 90 degrees, so that's why cos 90 0. So this power is 0. Okay. Power factor 0 now, that's why power is 0. Okay. The power dissipated in the circuit is phase difference is 0 now, 5 value. E given as what, tell me, E naught into sin omega t and I is equal to I naught into sine of omega t minus pi by 2. So phase is equal to pi by 2. So this power factor is what I mean now here cos phi, which is equal to 0. So the average power is 0. Next one. A 100 volts AC source supplies 10 amperes current. The average power delivered by the source is, oh, tell me now average power which is given as 1 by 2. They given already RMS value is only given. So directly we can say VRMS into IRMS into cos phi. So this is VRMS is a 10, IRM 100, 10, and this is cos phi. So this value will be how much now? 1000. Can I say 1000? 1000 multiplied by constant. We don't know this phi angle. Based upon this phi, if this phi is equal to 0,000, phi is equal to it is 90, will become 0 now. So this means can you say this value will be compulsory 1000? No. It may be 0. More than or less than we can't say now. That depends upon the phi angle. Okay. In a AC circuit, power is consumed by. Yes, the power. Who will consume the power? You tell me in AC circuits. Who tell me now here? Power consumed, dissipated, and power consumed, dissipated, delivered. Everything will be done by the resistor only. Next, in a LR circuit, the inductive reactance is equal to R of the circuit. Okay. Means they are saying that XL is equal to R. That means current will be what? Tell me now here. V by V naught cos omega t by square root of what? Tell me now here. R square plus R XL square. Na? So simplify this thing here. E naught into cos omega t by XL is equal to R. So it will be root 2 into R omega. This is I. So this is I is equal to what I will get to tell me now here. E naught by root 2 into R. And what about this IRMS? Again by root 2. So this is E naught by 2R. So this power which is what tell me now here. IRMS square into R. That is P is equal to what I will get tell me now here. E naught squared by 4R. 4R square into R. So this P value E naught squared by 4. The current and voltage in AC circuits are given as like this. The power consumed is. We need to find the how much the power consumed, right? Yes. So now you can see now phase difference between them. It is a 0. So power factor is 1. So power is non-zero. So P is equal to what we can say now here. I naught V naught by 2. Option B. An alternating current having peak value 14 amperes is used to heat a metal to produce the same heating effect. So we should find RMS value. So I naught value given as what element of 14. We need to get what element of here. Yes, so this is RMS value, which is equal to what we can say 14 by root 2. Okay, so this value 10 into we can say 1.414. by root 2. So this value is about 10. For a series LCR circuit, power loss at a resonance is the power loss is what element of P, which is nothing but what element of I square into R now simply. Next, in a series RC circuit, power consumed is which element will consume the power? Only the resistor will consume the power, right? P given as what element of here? VRMS into IRMS into what element of cos phi. So this thing we can say this as VRMS square by Z into cos phi. That is VRMS square Z into cos phi is equal to R by Z. That is V0 square by 2Z square into R. So how much this power P will becomes what? Tell me. V0 square. So 282 square by 2 into Z square. That is impedance now, not given. So we should calculate. Z is equal to what element of square root of what? R square plus XL minus XC whole square. Simplify it. How much will come? That is R square, R value 400 square plus XL value, XL is omega value, so XL value omega is what? Tell me now, 377 into L is what? Tell me, inductance. Oh, inductance not given, so any capacitance is there, so this value 0. So capacitance is what? Tell me now, 377 into, yes, 1 by omega C, omega C value how much? 2 into 10 power minus 6. Simplify this thing. XC value. Yes, only this little bit of calculations here. So this is XC whole square. Now the Z value, we can calculate this thing. Z value will come it as 1417. Check calculate. Now, so place the power, which is equal to V0 square 282 square by 2 into what element of Z square. So this 1417 whole square into R is 400. So you can simplify this one. 282 square into 500 into 2 into 1417 cos square. So this value will come it as what element? 9.9 watts. So which is equal to 10 watts. Okay. So this thing we got it. Fine. Yeah. Okay then, that's for the today's sessions, and we'll see in the next class. See you. Bye bye.